The first question that I want to address today is, why should we care about argumentation? Where all these come from? Why this is a good idea to look into? And my point is pretty simple, in the sense that argumentation is at the base of scientific inquiry, dialogues, most of the activities that we as humans or we as a scientists do every day. So let's consider a simple question. And a simple question might be, well, very hot topic right now, can be, does MMR vaccination cause autism, right? It's a true question, it's a reasonable question to pose ourselves, and is one of those type of questions that scientists try to address every day. So you have a research hypothesis, and you try to figure out whether there are data backing up this hypothesis or not, right? So as any other scientist, the first thing that you might want to do is just look online and see what is there. And you find out that there is a paper, an early report that is written by a bunch of people, published on The Lancet. And okay, it looks that it's addressing the same question. And you start reading the paper, and inside you can see the findings. Let's say that there are some behavioral symptoms, i.e. autism, associated by the parents with measles, mumps, and rubella vaccination, etc., etc. And they provide arguments. They provide a reason to believe this conclusion. And the reason is a bunch of data, especially the analysis of 12 patients, that show some correlation between a behavioral diagnosis of autism and an exposure to the MMR vaccination. To be fair, in the same paper you can also read in the discussions whether, well, we are not exactly sure if this is an actual causal link. So the author of the paper actually said that we are not entirely sure this is a causation. And at the same time, they also say that there are potential other explanations. So in the same paper, you have a conclusion. We have some data backing up this conclusion. So we have some support here. And we also know that there are reasons that might give other explanation, or there are potential reasons not to believe the link between this data and this conclusion. Now, what they do in this paper is basically creating an argument in favor of the conclusion MMR vaccination cause autism. And in the argumentation community, we had people formalizing those argumentation schemes. So those patterns of reasoning that we are using every day in putting forward our conclusion and backing up those conclusions. And an argumentation scheme is nothing but basically a scheme that says there are some premises, there are some conclusions. So in this case, you have that if an hypothesis is true, then a proposition reporting an event will be observed to be true. So if you observe B, then you have to conclude that A is the case. So this is basically what we are trying to do. When we have a research hypothesis, you say, well, if we have some data backing up this hypothesis, then the hypothesis is true, right? But at the same time, Walton and colleagues, they also propose what they are called critical questions that are even more important than the structure itself. The critical questions are allowing you to identify whether the argument is strong enough or whether there are other arguments might be important to be considered, or whether there is any way to strengthen or weaken the argument itself. So you can ask yourself, is it the case that if A is true, then B is true? Is there a causal link between the two of them? Could be there some reason why the data is true other than it's being because of A being true. So there are alternative explanations for the same phenomenon. So the connection between critical questions are trying to help us to minimize our confirmation bias, our other bias related to be too much focus on a specific explanation, etc., etc. So what you read in the paper matches very nicely what we already had from the philosophical area of our community that is very much interested in formalizing those reasoning patterns. But let's move on. So we started from the question, does MMR vaccination cause autism? We found a paper, that's fine. And then we go on, we find another paper, perhaps, published in the New England Journal of Medicine, a few years after the previous one. And actually, we can find that this paper because it is citing the previous one. And we can look inside, and it's actually very much written in order to provide counter-argument to the previous one. In particular, the main conclusion of this paper says that there is no association between the age at the time of the vaccination, the time since the vaccination, or the date of vaccination, and the development of autistic disorder. So the study provides strong evidence against the hypothesis that MMR vaccination causes autism. And they backed up this statement, this conclusion, by an analysis of 500,000 children in the Netherlands. So this is, if you just read this paper alone, you have just, okay, this is the conclusion, and this is backed up with this data. But now we can merge the information we have from these two different papers. So we can say, okay, the original paper will say there is a correlation between MMR vaccination and autism, backed up by an analysis of 12 children. The authors of this original paper considered the case that there were potential alternative explanation. And they also question themselves a little, say, well, we don't know whether there is an actual causal link. And this is actually the analysis that has been provided by the second paper that says, well, there is no causal link. So in some way, this potential critique to the original argument is well-founded. We had counterexample, plenty of counterexamples, strong evidence that this is the case. The question that we now have is how we can build a machinery in order to help us to derive some conclusions by a set of evidence, a set of arguments and counter-arguments. And that is the argumentation theory. So what we had here can be represented in forms of logical entailment and rules and evidence in a very almost straightforward way. So what I'm going to show you now is one of the simplest way in the argumentation community created to formalize this evidence and links to the conclusion, and which is based on papers published in a special issue on the Argumentation and Computation journal, that is one of the main journals of reference for the community. And in this special issue, you can have a list of different approaches to structural argumentation. I would just consider one of them right now, the one that I consider the simplest. And the one that I'm going to consider is based on deductive argumentation. So it's very much focused on a logical aspect behind our reasoning on conclusion and premises. So Philippe Bernard and Anthony Hunter proposed the idea of, okay, if we start from a logical approach, we have some basic definition, like we have a language, we have to define a language for this logic, and we need a consequence relation, and we need a notion of complement. So whether a literal is a positive or a negative, and whether one is the negation of the other. So we have that if alpha is positive, then the negative is the complement, and vice versa. And given this definition, you can just say, okay, a deductive argument is a pair when we have some support and a conclusion. So you have the set phi, that is the set of propositions or logical formula, and then we have alpha that is entailed by phi. So we have this bit that is the premises of the argument, and alpha that is the conclusion of the argument. Otherwise, this can be called the support, and this one can be called the claim of an argument. So if we have we have a report that says rain, and we have an inference rule that says report rain implies carry umbrella, then this is an argument supporting the conclusion you should carry an umbrella. You can use whatever logic you want, but for the sake of this tutorial, I will just focus on the simplest logic that the author considered, which is just considering the entailment, just whether you have a rule, an inference rule, and whether you have all the premises of this rule backed up in your knowledge base, or whether you can prove those premises in your argument. So if you have this knowledge base, A and B implies C, and C implies D, then you can derive both C and D, but you cannot derive neither A or B, because there is no rule saying that having A or B as a conclusion. So this is one of the simplest logic that you can even think about that. Which means that, okay, given the definition I gave you before of a deductive argument, a deductive argument using simple logic is just an argument where you have some premises here, a conclusion that is derived. It can be entailed using the rule, the entailment rule I just gave you in this slide before. So you have, if you have this in your knowledge base, then because you have this inference rule, and if you have this as part of your argument, then you can infer that it's a good investment, invest in the British Petroleum, given the fact that there is this inference rule oil company and it's a good performer, and you have this backed up in your knowledge base. Now, so far is pretty straightforward. The question is how we can represent conflict among arguments. And in the case of the simple logic, we basically have two main types of conflict. The first one is when you have an undercut. So you have an argument providing a reason not to believe the premise of another argument. And rebut is when you have an argument putting forward a conclusion that is the opposite conclusion of another argument. So the undercut is attacking the premises of an argument. The rebut attacks the conclusion of an argument. So you have, if we take these two simple examples, we have efficient metro. If you have an efficient metro, you can use the metro. Therefore, you should use metro. And then you have that strike links to the not having an efficient metro. Therefore, the metro is not efficient. This contradicts a premise in the first argument. So this is a case of simple undercut. A2 simply undercut A1. Instead, if you have that you have government in deficit, and if you have a government in deficit, you should cut government spending. Therefore, you should cut government spending. And this is argument A3. But if you have a weak economy, and weak economy implies you should not cut a government spending, then you should not cut government spending. These two arguments are contradicting each other in the conclusion. So you have a simple rebut between the two of them. Note that in the first case, the attack is from one argument to the other. In the second case, the attack is mutual. So in this case, A2 simply undercut A1, but A1 has nothing to do with A2. In this case, A4 simply rebut A3, but also A3 simply rebut A4. Okay? So given this simpler definition, if we come back to our problem before, we had this situation here. The question is how we can transform this situation here into a knowledge base with some rules. Although it might seem trivial or simple or straightforward, there are people studying this problem since almost a decade, and there are different ways to address this issue. What I'm going to show you today, once again, is the simplest case. This is also bringing an issue, a much more wide issue, which is linked to how we do formalize things into logic, which is a topic, a philosophical topic per se that we are not going to touch today, but I'm pretty sure that each of us are very aware of the issue of moving from a natural language statement into a logical statement. You have many ways to represent the same thing in a logical language. So the formalization that will happen in the next step is highly questionable. We all agree with that. There are infinite ways to represent the same situation. What I'm going to show you right now is not the perfect one, it's just one of them. Also because we don't have a measurement of perfection. So that is another issue. So we can start say, okay, we have some data from the original paper of Wakefield, and unless we have alternative explanation, and assuming that we have a causal link, then the vaccination is the cause of autism, right? This was the main argument of the previous or the original paper. And we have this evidence because the original paper gave us a table with 12 children, analysis of 12 patients. In the original paper, they said we have no alternative explanation, and I forgot to add that they assume that it was a causal link. And then we had that the second paper said, well, if we can prove that there is no association between these two situations, then we can disprove that it was a causal link. To get that there is no association within a larger study, and we got a large study. So the first argument, that is the argument of the first paper, that was saying, of this A2 is the argument of the original paper. It says we have the table with all the information there. We have no alternative explanation. We also have a causal link, missed in this slide, apologies. And given the link, that's table, not alternative explanation, causal link implies the cause of the autism is vaccination, then we can conclude that the vaccination is the cause for autism. And then we have instead the second paper that comes in and said, well, we have a large study. The large study says that there is no association. The not association implies not causal link, which means that there is no causal link there. And if you remember the definition we had before, we had that this simply undercut the second argument, because it's providing a reason not to believe one of the premises of the second argument. If you start moving from this representation, you can see that now we can start seeing arguments as an atomic element. We stop looking inside the single proposition inside an argument, and we just say, okay, what is the acceptability status of a single argument? once we have an acceptability status of an argument, whether an argument is acceptable, makes sense or not, then we can go back and look at the single proposition inside that argument and see which of those propositions makes sense. Which means that if we have that argument A2 is reasonable, well, it means that we should look inside the propositions of the argument A2 and see, okay, vaccination is the cause. But if you actually have reason not to believe the argument A2 as a whole, then we can disregard at least the conclusion inside the argument A2. Which means that we can abstract from what is inside, and we can just look at the relationship between arguments, and the relationship between those arguments will be based on the notion of attacks or conflict. In particular, the simple rebut and the simple undercut I showed you before, but there are many others. Which means that the acceptability status of an argument, if we start looking at an argument as a single atomic unit, does depend on the acceptability status of the other arguments as atomic units and the relations of conflict among them. And this is the intuition behind one of the most cited paper in artificial intelligence, that is on the acceptability of arguments, a fundamental role in reasoning logic programming and Python games of Fan-Min Dung, which introduced the concept of abstract argumentation, which is exactly what I described before. An argument is an atomic element, and those atomic elements of argument are related to each other through the notion of conflict.